can try to rejoin the meeting after the. Okay. Okay. So now our recording has got started. Fine. So we were talking about a postfix evaluation, how to evaluate a given postfix expression. So we have converted a given infix into a postfix expression, and now we are talking about evaluation of this postfix expression. So what does the algorithm says? If you see here, so the algorithm says that you need to start scanning the expression from left to right. Left to right means index value 0, and you will go one by one to right side, so till you reach the last character or the last symbol. So the first statement or the first step of the algorithm is read the next element. Okay, whatever is the next element. If it is for the first time, then it would be the first element. If element is operand, then push the element in the stack. So when you read the element, see, this is postfix expression. When we had infix expression, and whenever you read an element from an infix expression, what were the possibilities? There were four different possibilities. First possibility, it can be an operator. Second possibility, it can be a left para. Third possibility, it can be a right para. And fourth possibility, it is an operand. Only four different possibilities when we are reading an infix expression. Likewise, when we read an element from a postfix expression, so we all know that a postfix expression does not have left para or right para. Left and right parentheses are not present in the postfix expression. It means that in postfix expression there are only two possibilities. Whenever you read a symbol or an element from a postfix string, either you are going to read an operator or you are going to read an operand. I repeat, you are going to read an operator or you are going to read an operand. It means that into this algorithm, basically we will be doing something only for two different possibilities. One possibility is an operator and second possibility is an operand. Okay, so that's what the algorithm says. The second step is, if element is operand, then push the element in the stack. So when we read the element, and if the element is found to be an operand, then we need to simply push it on stack. Okay. What is the second possibility? If element is an operator, then, so if the element is an operator, then what to do? Into this, you have few multiple steps. All those steps are quite simple. Let's see. If the element is an operator, then first thing you need to do, pop two operands from the stack, and then pop one operand in case of not operator. What is the first sub step into this third step? If an operator is encountered, then the first thing you need to do is pop two operands or pop two elements from the stack, because into the stack we have operands, so we'll be popping the operands. How many operands we need to pop? Two operands. If it is a binary operator, if it is a unary operator, then you need to pop only one operand. Okay, so I repeat, if the encountered symbol is an operator, so we need to perform pop operations. Two pop operations if it is a binary operator, one pop operation if it is a unary operator. The next substatement is what, or substep is what? Evaluate the expression formed by the two operands and the operator. Okay? You have popped two operands from the stack, and then you have already an operator which has been encountered. Now you need to perform the operation of this operator into these operands, into these two operands, and then whatever is the result, that result you need to push onto the stack. Okay, I repeat, evaluate the expression formed by the two operands and the operator. We have popped two operands. One operator we have already encountered, we have scanned the operators, that's why we have popped two operands. Then we'll form the expression using this operator and these two operands. If the two operands are, for example, A and B that we have popped from the stack, and the operator is plus, so we will form the expression A plus B. Okay, we'll evaluate this expression, and whatever is the result, we'll push this result onto the stack. we will push this result onto the stack. That is the third sub-step of this step. What is the third sub-step? See there, push the results of the expression in the stack. Okay. Next step is what? If no more elements are there, means you are scanning 1111 elements, the entire string has been scanned and there are no more elements, then whatever is there into the stack is your result. So pop the result, else go to step 1. If there are more elements still remaining in the expression to be scanned or to be read, then we'll move back to the first step, that is read the next element, then check if the element is an operand, push it onto the stack. If an element is an operator, then perform 2 pop operations in case of binary operator and 1 pop operation in case of unary operator. Okay, form the expression, evaluate the expression, push the result onto the stack. Okay, then if there are no more elements to be read from the postfix expression, then your result is onto the stack, pop that result, display the result. Else go to the step 1. Okay, and repeat it. So you will be doing this till your postfix expression is exhausted, till your postfix string is completely scanned or completely taken care of. Okay, let's see an example of this. What we'll be doing, we'll be directly solving the example instead of seeing the example. And for that, let's move to our code. Just a minute. You will be seeing only the algorithm in front of you. No issues. Let me open the code and share it with you. Now, let me share our Visual Studio Code window with you. Okay. Fine. So now this is my code for postfix evaluation. So here, first of all, we will solve our example. Some example. Now, suppose the postfix string which is given to us is something like ABC star plus. Can you tell me what is the infix of this ABC star plus? And then the values of A is 1, B is 2, and C is 3. Okay, so these are the values. Now we need to evaluate this given postfix expression ABC star plus. Okay, again, can you tell me what is the infix of this ABC star plus? Please put your answer into the chat box. What is the infix equivalent of the postfix expression ABC star plus? It is simple. A plus B into C. A plus B into C. Yes, absolutely right. It is A plus B into C. Okay. Now, let's go for evaluation. What does the algorithm says? The algorithm says that you need to start scanning the postfix expression from left to right. So the way we have solved the postfix infix to postfix conversion example, in the same way we will be solving this. So let me write it as step 1. So what is the step 1? What will be encountered when we scan the given postfix ABC star plus from left to right? A is encountered. A is encountered. What to do? What is an A? A is an operand, and whenever an operand is encountered, what we need to do? We need to simply push it onto the stack. Okay. So here I would be saying stack. Let me write here. Stack is I am pushing A onto my stack. Done. Then my step 2. B is encountered. What to do? It's an operand. So we'll be simply pushing it onto the stack. So after A, we have B. B is on the top of the stack. B is on the top of the stack. Then the third step, step 3, what is encountered? C is encountered. It is a very simple example, but likewise you can easily solve any other example. The content of stack would be A, then B on top of A, and then C on top of B. So C is the topmost element in the stack. And then step 4. Now see here carefully. Step 4. So when we scan the fourth character, then the fourth character is star. So star is encountered. What is star? It is an operator. So whenever an operator is encountered, what we need to do? We need to perform 2 pop operations. I repeat, we need to perform 2 pop operations. So the first pop operation would give you C. The second pop operation would give you B. Now see here very carefully what I am doing. I would say star is my binary operator. I need to perform 2 pop operations. The first pop operation would give me an operand. The second pop operation would also give me an operand. Okay? An operator is there, star. Now the first pop operation would give you second operand. So I would be writing something like this. OP2, operand 2, or let me write it completely. Operand 2 equals to C. I perform the first pop operation. Okay? And then operand 1 equals to B. Okay? And then I perform my expression. What is my expression? Operand 1, operator, and operand 2. Okay? So I would be writing like this. Operand 1, okay? Then the operator, and then operand 2. So this expression becomes like this. Operand 1 is B, then operator is star, operand 2 is C. Okay. This equals to what? What is the value of B? B is 2, then into C is 3, 2 into 3 equals to 6. So this is my answer of this expression. What we need to do? Push it onto the stack. So when I perform 2 pop operations, so C and B was popped. So what was remaining in the stack? A, and then on top of A, I push this result 6. Okay, see it carefully. Huh? First pop operation gives us second operand. I repeat, first pop operation gives us second operand. Second pop operation gives us first operand. Then step 5. What is encountered? Plus. What to do? It is an operator. So it's a binary operator. So perform two pop operation. The first pop operation would give you second operand, and the second pop operation would give you first operand. So here also I write operand 2. No need to write it again and again. I am just writing it for the sake of explanation. Or else I can directly form the expression. For example, when I pop, then I get 6 first and then A second. So 6 would become my second operand and A would become my first operand. So my expression becomes A plus 6. Okay. And that's what I'm going to write here. Operand 2 is 6. Operand 1 is A, and my expression becomes A plus 6. The value of A is 1, so it is 1 plus 6, which equals 7, and this I would be pushing onto my stack. Now, when we have performed two pop operations, the stack got empty because there were only two elements. Okay, so when I push 7, so 7 is the only element in my stack. That's all. What is the next step? The next step is what? After plus, you do not have anything over here. Your string has got exhausted. Okay. So since the string has got exhausted, there is no next step. And what we need to do, whatever is there into the stack, that is the result of your evaluation. You need to just pop it and display it. So I would be saying result equals to pop the stack and you get 7. So 7 is the result of the evaluation of this postfix expression. Okay. If you convert into infix and if you put up the values, then you will easily get it. Now, let us try to understand what are the advantages of evaluating a postfix expression. Why did we say that evaluating a postfix expression is easier and faster as compared to evaluation of infix expression for the machine? So the reason is quite simple and straightforward. If you see this evaluation, what we have done now, in this entire evaluation, we need not have to worry for any opening or closing parentheses or brackets. And the most important thing, we did not have to worry about the precedence of the operator. I repeat, we need not have to worry about the precedence of the operator. We need not have to worry about the priority of the operator. The precedence, the priority are already taken care. I repeat, the precedence and the priorities are already taken care. While evaluating, you did not have to worry about the priority or the precedence of the operator. The way the operators are coming, we need to keep on evaluating them. That's all. We did not have to worry about the precedence. If you go back and if you see the infix of this postfix, so the postfix is A, B, C star plus. The infix of this would become, as you people have already said, A plus B into star. Okay. Now, when you solve this simple example, simple infix expression, A plus B into C, and your values are 1, 2, and 3. So, if you do addition first, 1 plus 2 is 3, and then 3 into 3 is 9. Okay, the result is wrong. So, what we need to do, we need to keep the priorities intact over here. We need to understand what are the priorities of precedence of the operator. So in A plus B into C, we need to first perform the multiplication and then only addition. And then only we would be getting the right result. So A plus B into C, in this case it is 1 plus 2 into 3. So first multiplication 2 into 3 is 6. 6 plus 1 is 7. If you do not take care of these priorities in infix evaluation, then what would happen? You will get a wrong result. See, instead of multiplication, if we perform addition first, so 1 plus 2 into 3. So 1 plus 2 is 3, and 3 into 3 is 9. So your result is wrong. Okay. But if you see this postfix expression, so there is no chance of getting a wrong result, because we need not have to worry about the precedence of these operators. The precedence are already taken care as per the position of the operators in the postfix expression. I repeat, the precedence of the operators are already taken care, are automatically taken care as per the position of that operator in your postfix expression. So we need not have to worry about the precedence. That is the biggest advantage of a evaluation of postfix expression. That's why the evaluation is so simple and so straightforward. Whenever you encounter an operand, push it onto the stack, and whenever you encounter an operator, if it is binary operator, perform 2 pop operations. If it is unary, then perform 1 pop operation. And when you are performing 2 pop operation, the first pop operation would give you the second operand, and the second pop operation would give you the first operand. Okay? Then make up the expression using the operand and operator, solve that simple expression, and then push the result onto your stack again. Keep on doing this. At the end of the postfix expression, whatever is there into the stack is the result of the evaluation of your postfix expression. Okay. You can take up any difficult example. So for that, what I can do, I can execute our program for infix to postfix conversion, and from there I can give you one postfix expression to solve. Just a minute. Infix expression is suppose a plus b into in bracket a minus c into b divided by b plus c. Okay. So this is my infix. One simple example for you. This is my infix, and the equivalent postfix for this is so this is the equivalent postfix. So this is your example 2, and consider the same values for ABC 1, 2, 3 and solve this example. Please solve this example and let me know the answer. This is my example 2. The postfix expression is given to you. Postfix is important for us, this postfix expression, and the values of the values of A, B and C are same, 1 and 2 and C is 3. So solve this example first, please. Let me know the answer. Operand, push it onto the stack, operand push, push, operand push. Operator, perform 2 pop. So B and C would be out, and your expression would become C into B. So C into B is 6. So then 6 would be on top of this A. then again an operator minus, then it would be a minus 6. A minus 6 is minus 5. Minus 5 would come on top of b, then again into, then b into minus 5. So 2 into minus 5 minus 10. So a minus 10, then a minus 10, then b again, then divide, then minus 10 divided by 2, that is minus 5. Screen is visible. Yes, screen is visible. What's the problem into that? My solution went. No. Okay, solve this, please. Step by step you can solve. And it was minus 5, and minus 5, and 1 plus minus 5, that is minus 4, minus 4, and then see. Okay, please tell me the answer. What's an answer of this? So that is for you to solve. Let me know the answer. And meanwhile, let's see the implementation of postfix evaluation. It is an application of stack. So we have stack as it is, the way we used to have. Now just instead of array name A, now I have put it as data. So no need to worry for this. And then the empty function is empty instead of is empty, that's all. And here I have used the ternary operator, which I have already explained to you earlier. Then the pop function, simply to push function to push the given element or the given data. Then the pop function to get the required data. Then we have the evaluate function. Now see what we are doing into the evaluate function. To this evaluate function, we will be passing a postfix expression which we need to evaluate. Okay. Here we got our evaluate function. Eval will be passing the postfix expression which we need to evaluate, and this would return us the result of this postfix evaluation. Now I am assuming that all the operands in the postfix expression is going to be integer, and so the evaluation of this is assumed to be integer, and that's why the return type of the function becomes integer. Okay. If you want to handle it as a floating point value, you can handle it, no issue for that. So now, in the main function, what we are doing, we are simply creating a postfix string and allocation of 1 byte to solve the problem associated with pointer and scanf. Then read the string from the user, enter postfix expression, we are scanning it into postfix. Calling the eval function, passing the postfix string, it will return you some result, and that result we are simply displaying over here. Okay. Now get back to our eval function. What we are doing inside the eval, we have some declaration, variable, and then of course our stack. Okay. And here I am writing st.top equals to -1. What is this? Initialization of a stack. Initialization of stack is must. So I have initialized the stack. So instead of having a function and then calling that function for the single statement, we are initializing the stack over here itself. Now you can ask then, sir, why did we have initialize function in the earlier programs? Because we wanted to understand how the functions communicate with each other. And when we wanted to understand that how a simple task can be done with the help of a user-defined function. And I still said that that is a recommended style of working. Okay. So instead of simply writing like this, we should have a initialize function and we should call it. Now, the main part of the coding start or the algorithm starts, scan the postfix expression from left to right. And I said you scanning of any expression from left to right simply means we need to start from index 0 and we need to go one by one till we reach the last character. So for I equals to 0, expr of I not equals to null, I plus plus. Then we are taking the symbol or the character into a variable c. So c equals to expr of I, and then switching between the values of c. As I already told you, there are only two possibilities, that the scanned symbol or the encountered symbol is going to be an operator or it is going to be an operand. Okay. Now, what we are doing here, see here, if it is an operator, now we are defining it for some operator. So plus, if it is a plus operator, then what we need to do? Perform the pop operations. First pop operation will give you operand 2. I repeat, first pop operation would give you operand 2. So OP2 equals to pop ampersand ST, and then result equals to what? See here carefully. Result equals to pop ampersand ST. So this is the second pop operation. This is the second pop operation which is giving you the first operand. So first operand and our encounter operator is plus. So the operator plus and then the second operand, that is OP2. So this is our expression. Expression will be solved. The result would come into rest, and then this result will be pushing onto the stack. The same thing we need to do for all the operators. I repeat, same thing we need to do for all the operators. So the second case is minus operator. If it is a minus operator, same style, perform the pop operation, it will give you the second operand, and then perform one more pop operation to get your first operand. So first operand, and then your operator is minus, and then your second operand. It will give you a result. That result should be pushed onto the stack. Likewise for star operator, likewise for div operator, and likewise for cap or dollar. Now cap and dollar both mean same, as I said you earlier also. It simply means raised to or power of. Okay? So we are making use of a power function over here. It's a library function. So pop ampersand st, that is the first operand comma second operand, and then the result we are pushing back onto the stack. If it is not any of these operators, if the scan symbol or if the character which we have just read, if it is not plus, minus, star, div, cap, dollar, if it is not an operator, then definitely it is going to be an operand. So the last case is the default case, and the default case says us that it is an operand, and whenever it is an operand, so what we are doing, we are pushing it onto the stack. What we are doing, we are pushing it onto the stack. Now see here carefully how we are pushing it onto the stack. Push ampersand st c minus 0, c minus 0, and then once this is done, so this is the main logic of the code. So this ends your switch case, this ends your for loop, and after your for loop, whatever is there into your stack, once your for loop is completed, means your postfix expression has been completely read. Okay, it is exhausted, no more characters to read. So whatever is there onto the stack is your result. So we'll pop that result and we'll return it. So here the last statement is return pop ampersand st. We'll pop from the stack, that is the result, and we'll return that result. Okay. Yes. Any query into this? Let us execute this code. This is my session 12. So for evaluating that code, I need to share the entire screen with you. So I'm stopping this. And again, I am sharing the entire screen. So I will be compiling session 12. session12.c, and let me execute. So on Windows machine, when I am making use of GCC compiler, after compilation, it creates an executable, and the name of the executable is a.exe. So I'm executing that a.exe. It asks me for the postfix expression. Now the postfix expression we are giving, see here carefully how we are giving the postfix expression. In the expression itself, we'll be putting the values. I mean to say, we are not going to separately define the values a equals to that, b equals to that, c equals to that. So if my expression is a, b, c star plus, if my expression is a, b, c star plus, and the values of a, b, c are 1, 2, 3, a equals to 1, b equals to 2, and c equals to 3. So my postfix expression becomes ABC, means for A I have 1, for B I have 2, and for C I have 3. So this becomes my ABC, and then my star, and then plus. Okay, and then I put enter, and the evaluation of this postfix is 7. Fine. Now, why I am giving an input like this? To simplify. It is as simple as that. Okay, I don't want to get into the complexity of making a code wherein I would be having the postfix expression like ABC star plus, and then I would be asking for the values of ABC. Yes, absolutely, you people are free to do that if you can do that. Okay, but here my intention was basically to implement and to explain the evaluation part, and not this kind of stuff. Okay, but you are absolutely free, so you can take up the expression in the form like ABC and so on, and then later you can ask the user, okay, what is the value of A, what is the value of B, what is the value of C. That will make your code little bit more bigger and a little complicated, because you need to then understand what are the contents of your postfix expression, and then for every operand you need to take up the value from the user. It's not a big deal, you can do that, for sure you can do that, but right now I am avoiding it, and I am taking up the values in the string itself. And what is the limitation of this? The limitation is simple, that your operand is going to be a single digit value. I repeat, the operand is going to be single digit value. So if you see a 1, 2, 3 star plus, so 1 is basically one operand. Okay, 2 is another operand, 3 is another operand. Okay, so likewise we are getting the value. And suppose I put up the example which we wanted to solve. This we wanted to solve ABC star. So let me put that. It is ABACB. ABACB. A is 1, B is 2. ABACB. So 1, 2, 1, 3, 2. ABACB. ABACB star minus star, star minus star, and then B B is my 2, and then slash plus C plus, uh, slash or divide plus C is my 3, and plus. Okay, so this was our second example which I have given you to solve. So let us see, when we give the same example to a program, so what output we get. Okay, so the evaluation of postfix expression is -1. When I also solved it, when I gave you the example, that time only I solved it, so I also get the same answer, -1. So if you are getting the answer -1, then you can think that your answer is correct. If you are not getting an answer -1 for any reason, please check all your steps properly. All those steps are quite simple and straightforward, so you should get the answer as -1. Okay, so that is your postfix evaluation. Okay, and I hope you must have understood this code also. It is quite straightforward and simple. And if you have a query on this, yeah, what is this C minus 0? This is nothing but the input which we are giving, these numbers. Okay, these numbers 1, 2, 1, and so on. These are basically treated as character. So that code is nothing but converting my character into a number. Okay, I need to say to my machine that this one is not a character, it is to be treated as a number. Okay, so that's why I'm subtracting 0 from it. It's basically playing with the ASCII value. So if you subtract 0, constant 0, I can say, from the ASCII value, so you get the number. Just hold on. I will be sharing your attendance now with you, and in a while let me stop the recording. Deshmukh awaits your